Hello everyone. In this project, we are going to discuss about the possibility of cancer in three stages like low, medium or high in given conditions. So first of all, you can see in the first cell, we are going to import some packages like pandas, sklearn, numpy, which we use for the analysis of the data and all. So in the first cell, we imported the required packages. In the next cell, we use pandas to read the file that's cancer patient dataset in which we have stored all the data related to all the patients. So moving to the next cell, we are going to see the number of rows and columns over there, either the data set size. So here we can see that the number of rows are 1000 and columns 26. That means we are going to train that on the 26 different features. So basically this cell represents the data information or the information of the data set. Here you can see the 25 columns which are named as index, patient ID, age, gender and all are non-null values. We are not having any null values or something like that. So in the next cell we are going to print features and prediction. Predictions is the label attached with every row. We are going to see the features and predictions separately. So here you can see the head of the dataset, and moving to the next, we are going to see the features of the dataset. So you can see the count in every column is 1000 only because we are taking 1000 rows over there, and rest of the data is shown here. Then we are going to do some sort of reprocessing like standard scaling so that we can reduce the influence of unbalanced data or unequal data more precisely. So here we have done some sort of descaling using standard scaler from sklearn. This is some sort of pre-processing and all. Then we are going to drop index because we are having index twice. You can see there 0 1, then index and first column as well. So we are going to drop that index from here, and then this is basically the head only. Then you can see the head of the prediction, low, medium, high. Now we are going to split the dataset into test dataset and training dataset so that we can use them as training and predicting the model accuracy and functioning of the model. So here we are using sklearn model selection train test split. So to split the dataset into two parts, then we can see the size 800 rows are on training and 200 are for the testing purpose. You can see they are randomly chosen so that you can see the head of the training datasets like 29, 25, 35, and with now we are going to do some sort of exploratory data analysis using Seaborn and all. This is basically used to how to see if any outlier is there or something like that. So we can see that no such outliers is over there. If any outlier will be there, it will be shown like here and or anywhere, but I do not see any outlier here. Then we'll print the head again, so you can see the head of the dataset, testing dataset. Information of dataset would be having like 200 rows. This is the information of test dataset, testing dataset. Then here you can see some sort of concatenation. Then correlation matrix. Correlation matrix is also used for it's the part of data analysis only. We can merge two features if they are correlated to each other. You can see in this correlation heat map that if you see some similar kind of patterns in the two different features, so we can merge them to avoid the unnecessary complexity of the model. It would be easy to train the model if we can do so. So next, we haven't used any merging of the rows features, I think. Moving to the next part, we are using SVM classifier in the project. So we are going to import SVC support vector classifier from sklearn. So we are importing SVC from sklearn.svm, and then we'll start training and all. So you can see we have trained the model here, and it has taken like 0.0175 seconds because it was done for a very small dataset. It contained only 1000 patient dataset, so it took no longer. And here we have used confusion matrix to predict the accuracy of the model, and we can see that it is showing 100% accuracy. These are basically diagonal elements which shows if they are correctly predicted or not. The sum of these diagonal elements will be 200 because we have used 200 rows as the data as testing dataset, and we can see that the sum is going to be 200 only, and each of them is predicted correctly only, and the accuracy of the model shows 100%. So, and we can even check that on the testing dataset, and it is showing all the good accuracy, 100% accuracy, and it is also like not predicting anything to any different thing. We must have used one hot encoding in this also to labelize the output high, low, medium into 0, 1, 2, so that the model can understand that casually. So in the end, we can see that model is performing well and good, and we can extend it for the larger data set if required. Thank you.